Below is a file with systolic and diastolic blood pressure measurements. You want to plot this data in an individual and moving range control chart, but the assumption in using that chart is that the data is normally distributed. Well, at least roughly normally distributed. Check both systolic and diastolic data for normality and answer the question, can we use IMR control charts? Upload your conclusion and analysis for your Master Black Belt. Here's our data in a BlueSky data set. This is a fairly small sample. There's only 20 blood pressure readings for both systolic and diastolic. And normally we could use an Anderson-Darling test to determine this, but it's not really that valid or reliable for small samples like this. So what we're going to do is we're going to ask BlueSky to fit a curve to this data. And in the process, BlueSky will generate a whole set of graphics that you can use to assess the fit. The procedure you want is in the analysis menu of BlueSky and on distribution analysis. So click that. A menu will drop down and you can calculate an Anderson-Darling normality test. But what we want is a distribution fit. So I'll start with the distribution fit. So we've done that with this data. And we fit a univariate distribution to non-censored data. And you don't need to know what non-censored is. That's a reliability engineering term. When you check the normal box, copy systolic into the box, and click the execute dialog, you get the output shown in this output box. So it starts with a summary of the data, a number of statistics called information statistics, the distribution we're trying to fit, and some information on the computer's algorithm for trying to fit the data. It generated some goodness of fit statistic, Kolmogorov-Smirnov, Kramer-Van Mises, Anderson-Darling, and these statistics are shown. It doesn't give us a p-value, but I think the Anderson-Darling test will. In any event, I can show you that you can ask AI to give you the p-value, and it will give you that. So for example, here I asked AI, what is the critical value at the 5% level for the Anderson-Darling test with n equals 20? And the AI responded, for a normal distribution with n equal 20 and a significant level of 5%, the critical value is 0.751. Since our critical value does not exceed 0.751, we can conclude the Anderson-Darling test will find this to be normal. But I want to look at some plots because I'm kind of a graphics person. And here are several different plots that we can look at. And here's a histogram with a fitted normal curve. And you can see that the data doesn't look at all normal, but it's because probably it's such a tiny sample size. A QQ plot is another way of looking for normality. So does our normal theoretical quantile equal our empirical quantile? And it looks to me like that line fits pretty well. Likewise with the cumulative density function, this normal curve, the red line, fits the data pretty well, and the PP plot does as well. So based on this graphical output, I would conclude that systolic is sufficiently normal to use an IMR chart. Now let's run the same analysis for the diastolic data. So distribution analysis, distribution fit, diastolic, choose it. Choose normal. Execute. And here's our diastolic data. So there's diastolic data, same set of statistics. and goodness of fit criteria. And you see here, Anderson-Darling is getting kind of close to what the AI said was the critical value. So 0.751 is a critical value, and Anderson-Darling is 0.7481. So it's pretty close to our critical value and kind of suspect. So once again, we need to look at the graphics to determine what we are really looking at here. And once again, the histogram is pretty worthless because of a small sample size. The QQ plot shows, to me, a pretty good fit. The straight line represents a normal distribution, and the data points scatter around that line in what looks like a random fashion. Likewise, the theoretical cumulative density function and the data points also follow a pretty good fit, as does the PP plot, where we have theoretical probabilities versus the empirical probabilities. So in my humble opinion, I think this data is good enough for normal to use the individuals chart. Not to mention that the individual chart is very insensitive to even pretty significant departures from normality. So I would use this data on an IMR chart without hesitation. I promised to show you how to use the Anderson-Darling in BlueSky's distribution analysis. So if you click that, click down to this one, pick Anderson-Darling normality test, copy your systolic and diastolic variables into the target, click the execute dialog, and BlueSky will give you the Anderson-Darling test, which includes a p-test. So you see the test for systolic, p-value is 0.5971, which is more than 0.05. So this is a good enough fit for normal. This is 0.0502, which is slightly higher than 0.05. So technically, you could assume this is a normal data, but as we saw, the graphics give us much more information.